we're gonna learn how we write numbers in a scientific notation. If you remember, scientific notation was some kind of a number that we had that was 1 or greater than 1, however less than 10, right? So we have some kind of a number times 10, always times 10, no matter what, times 10. And then we have some kind of an exponent, and the exponent is telling us if the number is less than 1 or if the number is greater than 1. In here, we have for problem number 1, 50,000, right? Well, 50,000 is bigger than 1. And we said if the number is bigger than 1, what kind of exponent we have? Positive exponent, right? So if I was to write this as a scientific notation, I have some kind of a number times 10, and I know my exponent, because this is bigger than 1, I know that the exponent in here has to be positive because this is bigger than 1. Now, the rules of exponent, right, of scientific notation says decimal point has to be after really the first counting number, right? Because that's the only way to have that number, the number that goes over here, that will be 1 or greater than 1 and less than 10, right? So the decimal point has to be after the first counting number. So the first counting number is 5. So I know in here, what do I have? I'm gonna have the number 5, right? And if there was another number in here, it will be 5 point some kind of a number, but there's a 0, I don't have to write the 0. 0 is insignificant. 0, if after it is after the decimal point, means absolutely nothing, right? So I have now 5 times 10 to a certain power. Exponent has to be positive, but what kind of exponent, right? What is it? Well, let's see, how many places did we move that decimal point? 1, 2, 3, 4, right? So this is gonna be to the 4th power. Let's look at it here. I know I have to have some kind of a number times 10, right, raised to an exponent. What is that number? Well, my first counting number in here is the 6, right? And then there is afterwards is 83. So I have 6.83. If I look in here, 683, right? It's greater than 1, so I know the exponent is positive. And we said that the decimal point has to be after the 6. How many places did we move the decimal point? 2, and it's positive 2. In case you wonder, where am I moving that decimal point from? If you look at any number, even if I was to give you number, this is just an example, even if I was to give you just number 2, right? Well, you don't see a decimal point, but there is one, and the decimal point is over here. It's really 2.0 or 2.00, right? But we do not write it. The decimal point is there even if you don't see it. Now let's look at this big old number in here. I know I have to write it as, in a scientific notation, it is some kind of a number, always times 10, and then we have an exponent, right? We have to figure out what number is it and what kind of exponent it is, right? If you look at this big old thing, you can notice that this is smaller than 1. So I know right away, that my exponent will be negative. I'm going to put that in there so I will not forget it. Then I also know that the decimal point has to be after the first counting number, which is that first 3. Now, how many places am I moving that decimal point? So it's going to be 3 point, and don't forget there's 3 after that. And because this is smaller than 1, my exponent is negative. Now, negative what? How many places are we actually moving the decimal point? 1, 2, 3, 4, 5, 6, 7, right? Till we reached where we want that decimal point to be. So my answer is 3.3 times 10 raised to the negative 7th power. Let's look at a couple more examples. Again, to write this in a scientific notation, I know I have some kind of a number, always times 10, and what I'm looking for is my exponent, right? If I look at this, right, I have 25 million, right? That is a little bit bigger than 1, correct? So I know my exponent will be positive. Now, how many places am I going to be moving my decimal point? Well, I know the decimal point will be after the 2. So it will be 2.5. And how many places did we move it? Because the decimal point, actually, there is 1, right? And it is 1, 2, 3, 4, 5, 6, 7. In this case, that 7 is positive. Number 4. A number times 10 raised to some kind of an exponent. This is smaller than 1. I know my exponent is going to be negative. First counting number is the number 5, right? So it's going to be 5 times 10 to what power? Well, let's see. 1, 2, 3, right? 3 places until that decimal point reach where it needs to be for here, right? A number times 10 to an exponent. Exponent, again, is negative because this is a decimal. The first counting number is the 5, so it's going to be 5.0. And look, there is number 6, so you have to make sure you incorporate it in there. How many places did we move it? 1, 2, 3, 4. 4 decimal places, and there's our answer. All right, and that's about it. This is how we will write any number in a scientific notation. Sounds good?